I'm continuing on problem 2. Here are radical questions, okay? Limit x approaching infinity and limit x approaching negative infinity. Square root of x squared plus 12x over 12 minus 9x and the same expression below. All right, so let's try that. Limit x approaching infinity, so this is positive infinity, radical x squared plus 12x over 12 minus 9x. So notice this is not a rational function because numerator is not a polynomial. It is a radical function. Okay. But the approach is similar. You would, in this particular case, look, radical is all encompassing the numerator. Okay. So what you would do is, look at this. Square root of x squared. X squared is the highest power inside. So square root of x squared is some kind of x. That's what you're aiming for. Downstairs is a polynomial. The highest power of x is x to the power 1. So why don't we divide by x to the power 1? Okay. So numerator divided by x, denominator divided by x. All right. Now, here is the fun part. Numerator is a radical. This is an x. And my x is going to positive infinity. That means x is positive. What do I know about x? If x is positive, x is square root of x squared. That's important to remember. X is square root of x squared if x is positive. Sorry about that. So, I will write this particular x, which is under the radical, as square root of x squared. Why would I do that? So, instead of writing just an x, notice I will write it as square root of x power 2. Okay? Why did I do that? Now I can combine these two square roots as one square root. That's the advantage. All right? So remember, I had an x before. I rewrote it as square root of x squared because x is positive. Once I do that, now I can divide. You see, I can distribute the division. Denominator also I can distribute the division. So what do I get? Denominator 12 over x and 9x over x gives me a 9. Okay. Whereas numerator, this x squared divides the x squared gets me a 1. This 12x over x squared, one of the x's goes away, but then I have another x in the bottom. Now I can take x approaching infinity, the limit. Okay. Look, once x starts to go to infinity, this quantity becomes 0. Okay. Notice once I apply limit, I no longer use limit. Okay, I don't write it anymore because it has been used up. This gets used up to make this 0. To make this 0. All right, both these guys become 0. What do I have upstairs? Square root of 1, which is 1, and negative 9. Negative 9. So 1 over negative 9 is negative 1/9. Okay, positive over negative is a negative. So negative 1/9. All right. Now the same expression, but I'm going to negative infinity. You see, why is this important? That's important because here, remember we said we had an x here. We replaced it by square root x squared because x is square root x squared. Now this is true as long as x is greater than 0. What happens when x is less than 0? I need to explain to you a little bit. Okay, so notice when take a positive number. See, if I want to take square root of positive 3 power 2, if I have to calculate this, this becomes square root of 9, which is equal positive 3. On the other hand, if I take square root of negative 3 power 2, I get square root of 9 again, which is, what happened? Okay, which is square root of 9 again, which is positive 3. So here there is an important distinction. When I put a positive number inside, I get a positive number outside. When I put a negative number inside, I get a positive number outside. You understand? This is why we say if x is positive, then square root of x squared is x. Okay? If I put a positive number inside, I get the same positive number outside. On the other hand, if x is negative, then square root of x to the power 2, I don't get the same number outside. I don't get the same number outside. In fact, I have to change the sign of the guy inside to get my answer. Do you understand that? If x is negative, minus of x is positive. No matter what I do, the outcome is positive. So when x is negative, I have to take minus x to make that guy positive. All right. So keep this in mind while we are going to go through negative infinity limits. When x is approaching negative infinity, let's go through the same process as we did before. Divide by the highest power of x, upstairs and downstairs. But in this case, x is negative, so I don't get square root of x squared is x. I get square root of x squared to be negative x. In other words, this tells me, oops, yeah. So this tells me x itself is negative square root of x power 2. All right. So when I see x, I put a negative square root of x squared. Negative square root of x power 2. All right. That negative is what survives. So these two square roots combine to be one square root, and that negative upstairs survives. Everything else is the same. All right. So I'm using this entire theory. All right. This is an important theory to keep in mind. Everything else is the same. Division distributes. So x squared by x squared is 1. 12x over x squared is 12 over x. Downstairs 12 over x minus 9. When I take limit x approaching negative infinity, when I take limit x approaching negative infinity, it doesn't matter. I still get a 0 here. I still get a 0 here. 1 and negative 9 are unaffected. So negative square root of 1 is negative 1 upstairs and negative 9 downstairs. Okay. Square root of 1 is 1, but a negative outside survives. This negative survives. So overall, it's positive 1 over 9. Submit. Good. Everything is good. All right. Until next problem then.